Hello! Today we'll take a look at how unit processes are arranged in our LCA model. We build our model and collect unit processes at the inventory stage of our LCA framework. Some say the most difficult part of LCA is the modeling. The inventory stage is where you build the model. If you want to use LCA for circular products, then you need to have a good understanding of the inventory stage. Later on, we will see how to adjust the inventory model for circular products, but first we need to know how to put the model together. Our model should reflect our product system and is made up of unit processes. But where should we begin? We begin by sketching a process flow diagram of our product system. The process flow diagram is a blueprint of our product system and is used to guide us in collecting and connecting the data in our inventory. The process flow diagram allows us to visualize where the different unit processes in our product fit into the life cycle of the product. It shows us how the processes are related to one another. In short, the process flow diagram is a qualitative representation of the structure of the product system. Remember, the process flow diagram can change as you progress through the LCA framework, since LCA is iterative. When sketching a process flow diagram, we need to be familiar with the different keywords or terminology used to describe flows in our product system. Let's go back to how we have defined a unit process and the flows in and out of the unit process. We have flows to and from the technosphere and flows to and from nature. These two types of flows have lots of different names in the LCA world, but we will use only one for each. First of all, we have flows entering our product system from the natural environment. We also have flows leaving our product system that go into nature. The term we will use for flows to and from the natural environment is elementary flows. Second, we also have flows in the technosphere, and actually these are the flows between unit processes. We will refer to these as intermediate flows. Our lifecycle inventory is the eventual list of elementary flows to and from our product system. But before we can make this list, we need to understand which processes are included in our system and how they are connected to each other. What are the flows that connect unit processes? Do you remember? That's right, intermediate flows. We focus on intermediate flows in the flow diagram because the intermediate flows reflect the dependencies between unit processes. Drawing up a process flow diagram of our product system requires a certain degree of abstraction, and therefore we aggregate unit processes where necessary. It's not possible to represent all the unit processes in the flow diagram, therefore some degree of aggregation is acceptable. Just remember that for the actual collection of data, you need the unit process level of detail. Now, let's see what such a process flow diagram can look like. We will use a plastic bread packaging or polyethylene bag example. It's a disposable polyethylene bag to package bread. Here we see the process flow diagram of such a plastic bread bag. Looks quite complicated, right? You can see many unit processes and intermediate flows. And you can imagine that, for example, the unit process ethene production is already actually an aggregation of multiple processes taking place. So let's use a simplified version and see what components in the process flow diagram we can identify. Our functional unit is one packaged bread loaf. We start with a single unit process or single aggregated process that occurs just before we get our functional unit. This starting process is our reference process. In this case, the packaging of one loaf of bread. Next, we need to think about the processes that happen just before and that will happen just after our reference process. We build up our process flow diagram by including all the necessary unit processes that we want to represent and connect them with intermediate flows. But what about elementary flows? Elementary flows must be accounted for. This is very important, and in fact, elementary flows are the whole point of the inventory stage. But we do not need to see them in our flow diagram. The elementary flows are recorded along with each unit process, but in our flow diagram, we are simply interested in how the processes fit together and how our product system is structured. So we leave the elementary flows out of the diagram. We have a border around the unit processes indicating the system boundary. Everything inside the system boundary is part of the product system. For each alternative product that you compare, you'll have to have a separate process flow diagram, and each alternative should have similar system boundaries. There are a few things you should notice about this process flow diagram. Firstly, transport processes are not reflected. This is possibly because the transport unit processes are aggregated along with the other unit processes. The flow diagram doesn't show the bread bag end of life stage. Including the end of life in the diagram is important, but it requires some careful thought, and we will look at this later. For now, the diagram represents cradle to gate. There are also products leaving the product system, such as kerosene and waste from the incineration of chemical waste. At the top, we have products entering the product system. We also have products entering and leaving the system along the sides. In principle, LCA should track all the intermediate flows and unit processes that are necessary for the product. However, this is impossible. Therefore, it is necessary to cut off product flows at certain points in your product system. That's another key word, cut off. For example, in this flow diagram, we have oil flowing into the system, crossing the system boundary, but we don't include the processes that produced this oil. Cut-offs can be justified when you believe that the unit processes you are cutting off do not significantly contribute to the environmental impact of your product system. This is a decision based on intuition. Is using your intuition a scientific way of making a decision about your system boundary? I'll leave you to think about that. There are two other reasons for implementing a cut-off: to separate your product system from other product systems, and when a process produces multiple products. We will look at this more closely later on. To briefly recap, the life cycle inventory is a list of all the emissions into the environment and all the resources taken from the environment by your product system. The process flow diagram shows us the product system with the unit processes. It guides us in collecting data, but at the end of collecting the data, we are interested in what is leaving the product system in terms of elementary flows. Are you ready to make a process flow diagram? Is there a product you think could be circular? What are some of the processes you would include in your process flow diagram for this product? I'll leave you to think about it. See you next time.